The material I am presenting is a metal called osmium. Element number 76, osmium, is an extremely rare transition metal that is most often found in the ore of nickel or copper. It has an atomic weight of 190.2 grams per mole and is tremendously hard and brittle. It has a blue and gray tint to it and is also very shiny and reflective even at high temperatures. It has the highest melting point and lowest vapor pressure of any of the platinum group elements. Its crystal structure is HCP or hexagonal closed packed. Its name comes from the Greek word osmi, which means smell or odor. Osmium is the densest element at about 22.59 grams per cubic centimeters. This is twice as dense as lead and 1.2 times denser than gold. Osmium was originally discovered in 1803 by a man named Smithson Tennant. He added platinum to a mixture of nitric and hydrochloric acid and noticed that not all of the metal had dissolved. Upon further research with acid and base treatment, he eventually discovered that this leftover residue was actually two previously undiscovered elements, osmium and iridium. Nowadays, osmium is produced commercially as a byproduct from the refinement of nickel or copper ores. Because osmium is so rare, it is often found as an alloy. This osmium alloy is usually mixed with iridium and simply called osmiridium. Osmiridium is desirable because of its extreme hardness and resistance to corrosion. This makes it a great material for fountain pen tips. This is because it is important that a pen feels smooth when writing. The osmium alloy gives the fountain pen tips an appropriate resilience and evenness required for the necessary smooth writing for many years. An example of an application of osmium in the past is the filament for a light bulb. Osmium was used as one of the original materials to create filaments for lamps. Because osmium is rather rare and expensive, these lamps were often rented and not sold. The lamp would be returned to the manufactory within 18 months, and then filament could be treated and reused. After only a few years, though, the osmium filaments were replaced with tungsten because it is more stable, luminous, and has a longer life. A possible future application of osmium is its potential use in UV spectroscopy. Osmium has highly reflective properties. A 600 angstrom, which is 600 times 10 to the negative 10th meters, piece of osmium has a reflectivity twice that of gold. This can be especially useful in the UV spectroscopy on space-based satellites or spacecrafts. When osmium-coated samples were launched in early shuttle test flights and then returned, the osmium layers seemed to have completely disappeared. This was due to oxidation in the upper atmosphere. In a later mission, a spectrometer containing osmium-coated grating deep in the instrument was sent up for 10 days. Upon return, it was found that the instrument provided proper shielding from the atmosphere, and the osmium coating remained. This is very promising as it means osmium has the potential to better our space technology. The main source of production of osmium is as a byproduct of copper and nickel ore refinement. Osmium is much harder to retrieve from these ores than the other platinum metals because of its tendency to very easily oxidize at high temperatures. It is estimated in the United States that for every 35 tons of copper that is produced, about 1 ounce of platinum metal is obtained. This is a very tiny amount even when compared to the amounts of other platinum group elements. The copper and nickel ores are usually refined through a process called electrolysis. During this process, the ore is used as the anode, and a thin rod of pure copper or nickel acts as the cathode. The anode and cathode are put into an electrolytic solution, and an electric current is passed through. Ions of the copper or nickel from the ore deposit onto the cathode. After the reaction has finished, the impurities on the anode that are left over to sink to the bottom of the solution as anode mud. These impurities, including the osmium, can be retrieved from this mud. A big safety hazard of osmium is that it tends to react with oxygen to form a compound known as osmium tetroxide. This compound is very volatile and acutely toxic. It is a severe irritant that can cause irreversible eye damage, including blindness. This has also been known to cause long-term damage to the liver and kidneys. It can also cause dizziness, headaches, and coughing. Despite osmium tetroxide's high toxicity, it does have some useful applications. One application is the use in electron microscopy. This is often used as a fixative and stain for the lipid biomolecules in vesicles and cell membranes. This process can allow scientists to look at intracellular structures most commonly used on lipid droplets in HeLa cells. Normally, it would be extremely difficult to see these structures even with a microscope, without a stain to make them stick out. This has allowed for greater development in the field of microbiology and tissue engineering.